Let's take a look at problem 4, which says a cone-shaped cup is made from a circular piece of paper of radius 18 inches by cutting out a sector and joining the edges AC and BC. So AC and BC. Okay, so find the maximum capacity volume of such a cup. So we want to maximize the volume. So we need to write the volume of the cup, which is a cone. So the volume of a cone is 1/3 pi r squared times the height. So we either need to replace the radius or the height or both. If you recall from problem 12 back in section 21, what we did was when we cut the sector out, the remaining part of the circle becomes the circumference of the cone. And so the circumference of the base of the cone is what's remaining. And so it would be 2 pi r times theta divided by 360. Well, r is 18, and we don't know theta, but we do know the circumference is going to be 2 pi r, where this r is the radius of the base, and this r was the radius of the piece of paper, the circle. And so now we know that r, which is part of our formula, r would be, when we divide by 2 pi, you would get 18 theta over 360. So I plug that in for r. And then the height of the cone. So now that we know what r is, the 18 theta over 360, then we can look at the height and the radius, form a 90-degree angle. And then this would be our slant height. Well, our slant height comes from this, and we're told that that's 18. So a squared plus b squared is equal to c squared. You would end up with h is equal to the square root of 324 minus the quantity 18 theta divided by 360, and then squared. And so, yucky. I plug that in for h. So now we have an equation with just thetas. So we can type that in our calculator. Well, once we type this equation in our calculator, we need to find some reasonable values for theta. Well, theta is this angle, and so like the smallest it could be is 0, which doesn't make a whole lot of sense. But then the biggest would be all the way around would be 360. And so I typed in 0 for my x-min, 360 for my x-max, and then we could find our maximum point. And so the maximum point was 293.9 and so on, and 2,350.684 and so on. Well, what do these numbers mean? Well, our x was our theta, and so that's the angle, and so that's in degrees. And then my y value, which is the volume, and so this would be the maximum volume, and it doesn't give us a unit, so it'll just be cubic units. Okay, so what does the question ask? It wants us to find the maximum volume, and so the maximum volume is our y value. So 2,350.684 cubic units. Okay, please take a look at the homework. Let me know if you have any questions, and I will talk to you later.